Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is types of probability distribution part 1, which will be going to focus on discrete probability distribution. So in our preceding session you have seen that how we have elaborately discussed about the probability distribution and how important the probability is, and as far as the distribution is concerned, because this distribution is going to emphasize more on the various ways of doing the thing. So we are here to talk more about the types of probability distribution 1, which is emphasized on discrete probability distribution, and there are many different classifications of probability distribution. Some of them include the normal distribution, chi-square distribution, binomial distribution, Poisson distribution. The different probability distributions serve different purposes and represent different data generation process. So either it could be the Bernoulli distribution, uniform distribution, binomial distribution, normal distribution, Poisson distribution, or exponential distribution. So in our preceding session we have seen that how this probability distribution is going to be bifurcated in discrete and in continuous, and as far as the discrete probability distribution is concerned, this probability distribution emphasize more on the possible values, has a non-zero likelihood. Furthermore, the probabilities for all possible values must sum to 1, because the total probability is 1 and one of the values must occur for each opportunity. So the examples are how many fleas are on prairie dogs in the colony. Discrete, this is known as discrete, and this is something you are going to count. So that is the reason we have called this as a discrete probability distribution. So we have already talked in our preceding session that probability distribution is going to be bifurcated in discrete probability distributions and continuous probability distributions, and as far as discrete probability distribution, which we are going to discuss in this particular session, more emphasize on binomial, Poisson and hypergeometric, whereas continuous probability distribution is going to talk on normal, uniform and exponential, which we are going to discuss in our next session under the ambit of types of probability distribution part 2, continuous probability distribution. So anyway, we are just emphasizing more on discrete probability distribution, and we start with one example, and that example is can only assume a countable number of values. For example, the dice is going to be done, and the role of a die twice is let x be the number of times 4 occurs, then x could be 0, 1 or 2 times, and if you are going to toss a coin 5 times, let x be the number of heads, then x is equal to 0, 1, 2, 3, 4 or 5. This is called discrete probability distribution. So we start with the binomial probability distribution, and there are certain assumptions to binomial probability distributions, which is the first assumption is that trials follow Bernoulli process. 2 possible outcomes are there. Probabilities stay the same from one trial to the next. Trials are statistically independent, and number of trials is a positive integer. So if you talk about the binomial distribution formula, it is explained by the factorial n divided by factorial r, and n minus r is factorial of n minus r. So this is the way by which we are going to do it, and p to the power r and q to the power n minus r is the formula of calculation of binomial distribution, where n is equal to number of trials, r is equal to number of success, p is equal to probability of success, q is equal to probability of failure, and factorial is a symbol which is quoted by this sign, exclamatory sign. Okay. So if we talk more about binomial distribution, probability distribution is a widely occurring discrete probability distribution, and outcome on each trial of an experiment is classified into one or two mutually exclusive categories, a success or a failure. The random variable counts the number of success in a fixed number of trials. The probability of success and failure stay the same for each trial. The trials are independent, meaning that the outcome of one trial does not affect the outcome of any other trial. So there are certain examples to this binomial, and each time the gambler plays the slots, there is 1 in 1 million chance of winning. Playing 1 million times is modeled by the binomial distribution, which is closely related to the binomial theorem. The probability of winning 0 times out of a million trial is this. So the other example is that, let's take example of a person like Shubham hits 60% of his free throws in basketball games. He had a 25 free throws in last week game. What is the average number of hits? What is the standard deviation of Shubham hits? What is the probability that he made at most 3 hits? What is the probability that he made at least 23 hits? So if we talk about the formula of binomial probability, I think the binomial probability formula is quoted by Px in bracket is equals to this what we can say C and X, where C is a combination, C denotes a combination, and pi x, pi to the power x, and 1 minus to the power 1 minus pi to the power n minus x. So binomial probability formula is quoted by Px, and it is equal to combination of nx pi to the power x and then multiplied by 1 minus pi to the power n minus x, where C denotes a combination, n is the number of trials, x is the random variable defined as a number of success, and pi is the probability of success on each trial. So if you talk more about the binomial probability, there are 5 flights daily from Pittsburgh via US Airways into the Bradford, Pennsylvania Regional Airport, and suppose the probability that any flights arrive late is 20. What is the probability that none of the flights are late today? So probability of x equals to 0 is combination of nx pi to the power x and 1 minus pi to the power n minus x is the formula, where combination is from 5 to 0, and value of pi is 0.20 and value of x is 0. So and 1 minus 0.20 comes to 5 minus 0, because the value of n is 5. So if we do it in if we do the mathematical calculation, the value of combination of 5 to 0 is coming 1, pi to the power x is coming 0.2, and then this 1 minus pi to the power n minus x is coming 0.327, and the total value is coming 0.327. So this is the formula by which we are going to calculate. So binomial probability, as far as the Excel calculation is concerned, I think this is the way, where in the x-axis you have number of late flights, at the y-axis you have got probability, and probability distribution for the number of late flight is coming to this. So cumulative binomial probability distribution is quoted by example. A study by the DTC Department of Transportation concluded that 76.2% of front seat occupants used seat belts. A sample of 12 vehicles is selected. What is the probability the front seat occupant in at least 7 of the 12 vehicles are wearing seat belts? So this is the formula by which we are going to do that. The value of x is varying from x is greater than or equal to 7, n is equal to 12, and value of pi is 0.67762. So what we have done, we have put this value in the formula, and the value from x to 7 is coming 0.902. Probability of x equals to 8, the value is coming 0.1805. If the probability of x equals to 9 is 0.2569, like that we calculate, and when we sum up, the value is coming 0.9562. So this is the way by which we have done it mathematically, and with the help of Excel, spreadsheet, we have got the probability this. So this is another way of calculating, and mean of binomial distribution is denoted by mu is equal to n pi, where and variance of binomial distribution is quoted by sigma square, where is equals to n pi in brackets 1 minus pi. So this is the formula by which we are going to calculate. And binomial distribution means and variance, there are certain examples to that, and for example, regarding the number of late flights, recall that pi is equals to 0.20, n is equal to 5. What is the average number of late flights? What is the variance of the number of late flights? And mu is equal to n pi. So this is the way by which we have calculated, and the value is coming 1.0, and if we take a sigma, that is standard deviation of this probability distribution, the value is coming n pi in bracket 1 minus pi, and when we calculate, it is coming 0.8. So mean and variance, another solution is that if we take with the help of formula, the mu is equal to summation of x into px, and sigma square is equal to summation of x minus mu square into multiplied by px, that is probability of x. So this is the way by which we have done it. And if we talk about the 5% of worn gears produced by an automatic high speed cartel bell milling machines are defective, what is the probability that out of 6 gears selected at random, none will be defective? So exactly 1, exactly 2, exactly 3, exactly 4, exactly 5, exactly 6 out of 6 is there. So this is the way by which the value is going to be calculated. Binomial probabilities for n is equal to 6 and select values of pi is this. So this is the way by which we are going to calculate, and binomial distribution have got a mega set, and 5% of the worn gears produced by an automatic high speed carter bell milling machines are defective. and what is the probability that out of 6 gears selected, a random none will be defective. So this is the way by which we have calculated with the help of the formula. So binomial shapes varying from pi, it's if you see the success is if the value of pi is 0.5 and is equal to 10, you get a figure in this way. If the value of pi is 10 and is equal to 10, the value you get a success in this way. If the value of pi is 0.2 and is equal to 10, you get a figure in this way. So this is called binomial shapes which varying from the pi constant, and this is the another way of presenting the thing. So we have talked more about the binomial distribution. Now we are much going to focus on the Poisson probability distribution. So a Poisson probability distribution, if you're going to talk about, it is more it's a fixed number of observations, and let's take an example like 15 tosses of a coin, 10 light bulbs taken from a warehouse. Each observation is categorized as to whether or not the event of interest occurred. Head or tail in each toss of a coin, defective or non-defective light bulb. Since these two categories are mutually exclusive and collectively exhaustive, when the probability of the event of interest is represented as pi, then the probability of the event of interest not occurring is denoted by 1 minus pi. So the constant probability for the event of interest occurring is pi for each observation. Probability of getting a tail is the same each time we toss the coin. So the Poisson distribution is the expected value, is based on the expected value, and if you see this expected value is quoted by lambda, and if we talk about the distribution formula, the Poisson distribution formula, it is coming to lambda x and e to the power minus lambda upon factorial of x. So this is the value by which we are going to calculate the Poisson distribution, and discrete variable model Poisson distribution could be somewhat looks like this when you plot a figure in taking the fatal crashes at the x-axis and this probability at the y-axis. So the Poisson probability distribution describes the number of times some event occurs during a specified interval. The interval may be time, distance, area or volume. Assumption of the Poisson distribution is that the probability is proportional to the length of the interval. The intervals are independent. So Poisson probability distribution is characterized by the number of times an event happens during some interval or continuum, and there are certain example which is going to somewhat defend this. The number of misspelled words per page in a newspaper, number of calls per hour received by Dyson vacuum cleaner company, the number of vehicles sold per day at one of the what we can say the car centers or the car showrooms, the number of goals scored in college soccer game. So Poisson probability distribution can be described mathematically by using the formula probability of x is equal to mu to the power x e to the power minus mu divided by factorial x, where mu is the mean number of the occurrences in a particular interval, e is the constant, 2.71828 is the base of the Neperian logarithm system, and x is the number of occurrences success. So probability of x is the probability for a specified value of x, and mean of a Poisson distribution is quoted by mu is equal to n pi. So the mean number of success mu can be determined in binomial situations by n pi, where n is the number of trials and pi is the probability of a success. So mean of a Poisson distribution is equal to mu is equal to n pi. So the variance of Poisson distribution is also equal to n pi. So Poisson distribution, there are certain examples which we have already taken. Assume baggage is rarely lost at the Indian Airlines. Suppose a random people of 1000 flights show the total of 300 bags were lost. Thus the arithmetic mean number of lost bags per flight is 0.3, which is coming 300 divided by 1000. If the number of lost bags per flight follows a Poisson distribution with mu equals to 0.3, the probability of not losing any bag is mu to the power x e to the power minus mu upon factorial x. If we put the value, the probability of 0 is coming 0.7408. So Poisson probability distribution, if we see with the help of table, and if we recall the previous illustration, that number of lost bag follows a Poisson distribution with a mean of 0.3, and using appendix B5, find the probability that no bags will be lost on a particular flight. What is the probability? Exactly one bag will be lost on a particular flight. So Poisson table for various values of mu varies from appendix B5, and this is the way by which we are going to calculate. So more about the Poisson probability distribution is that the Poisson probability distribution is always positively skewed and the random variable has no upper limit. The Poisson distribution for lost bag illustration where mu is equal to 0.3 is highly skewed. As mu becomes larger, the Poisson distribution becomes more symmetrical. So transmission service, if you see mu is equal to 0.7, muffler replacement is 0.20 and mu is equal to 6.0. So number of occurrence is this. So if you compare the Poisson with the exponential, I think because exponential is something which we are going to discuss in the continuous probability distribution, but anyway, if you compare the exponential distribution looks like this and Poisson distribution looks like this. So x-axis talks about the minutes and y-axis talks about number of phone calls. So now the third discrete probability distribution is known as hypergeometric probability distribution. The trials here are not independent and hence the fourth assumption underlying the binomial distribution is not fulfilled, and therefore we cannot apply binomial distribution here. So binomial distribution would have applied if we do sampling with replacement, that is if each unit selected from the sample would have been replaced before the next one is drawn. So in probability theory and statistics, the hypergeometric distribution is a discrete probability distribution that describes probability of k success, random draws from which the object drawn has a specified feature, in n draws without replacement from a finite population of size n that contains exactly k objects with the feature wherein each draw is either success or a failure. In contrast, the binomial distribution describes the probability of k success in n draws with replacement. So an outcome of each trial of an experiment is classified into one or two mutually exclusive categories, a success or a failure. The probability of a success and failure changes from trial to trial. The trials are not independent, meaning that the outcome of one trial affects the outcome of any other trial. Using hypergeometric distribution, if experiment is binomial but sampling is without replacement from a finite population where small n divided by capital N is more than 0.05. So hypergeometric formula distribution is like the combination of Sx and in brackets multiplied by combination of n minus s and combination of n minus x. So where capital N is the size of the population, capital S is the number of success in the population, x is the number of success in the sample, it may vary from 0, 1, 2, 3, and small n is the size of sample or the number of trials, and C is the symbol for a combination. So I think there are certain good examples which are there and a lot more you will find out. OK Place Toys company in Delhi employs 50 people in the assembly department. 40 of the employees belong to union and 10 do not. 5 employees are selected at random to form a committee to meet with management regarding shift starting time. What is the probability that 4 of the 5 selected for the committee belong to a union? So if we apply the hypergeometric probability distribution, and the solution is this, where capital N is equal to 50, S is equal to 40, X is equal to 44, N is equal to 5, where capital N is the number of employees, S is the number of union employees, small x is the number of union employees selected, and small n is number of employees selected. So what is the probability that 4 of the 5 selected of the committee belongs to a union? So now what we have done, the formula is same as we have talked about. Probability of x is equal to combination of S and x and multiplied by combination of n minus x and n minus x divided by combination of capital N and small n. So 40, we have put the values and the values coming for combination of 44, combination of 50 minus 40 with respect to 5 minus 4, and combination of 50 with respect to 5, and the factorial 40 is coming, factorial 10 divided by 1 by 9, factorial 40 divided by 50, factorial 50, and this is the mathematical calculation, and when you calculate all those things and put the number, the value is coming 0.431. So I think we have talked a lot about this particular thing, and this is part 1 of probability distribution, which was much focusing on the discrete analysis, and in a coming session we are going to talk more about the continuous distribution. So continuous probability distribution, which is one of the important aspect as far as the calculation of exponential or the nominal is concerned. So anyway, we will talk more about this particular aspect, and by this way we can wind up this particular session, and we will have emphasize more on the probability, which is a very important ingredient as far as the trend analysis is concerned. Thank you very much.